Good morning students, welcome back to operating system class. Already we have completed what is the process and process states and process schedule. Okay, what is the process? Process is nothing but programming execution. How many states we have? Ready state, running state, waiting state, suspended state, blocked state. Depends on the state. Means when the process moves from one state to another state, the state of the process will change. Okay, so to know the information about the process, here the operating system will say the process control block. That also already we have completed. And yesterday, what in the last class, not yesterday, in the last class, what we completed? Scheduling queue. What is the process scheduling and the process scheduling queue? When more than one process is waiting for the CPU. At a time, we can't execute more than one process. So what happened? This process process manager, it will load all the process from a secondary memory to a primary memory. So in the primary memory, what happened? Each and every process will be in a queue like this. Okay, and this is a CPU. Depends on the priority, and first comes inside the queue, that will be loaded into a CPU. Means arranging the process in the sequence. That is nothing but the scheduling queue. Understood? Scheduling, that is process scheduling. Scheduling queue means depends on the status of the process. Example, whatever processes are there in the memory, in the secondary memory, and the process which want to execute, that will be in a job queue. When all the process which want to execute, that will be moved from primary memory to the secondary memory to the primary memory, then that is called as a job queue. Okay, so means the process which are waiting for, which want to execute, that will be put in a job queue, and the process which are ready for the execution, that will be in a ready queue. Okay, scheduling, and the process next that will be loaded into memory. Next, if any process is waiting for a CPU, this any input and output devices input or output, then that will be in a device queue. Okay, next in the last class what I explained, scheduler. Scheduler is a software that will select one job from a queue and it will load that job into a processor. That is a scheduler. Okay, means it will pick one job from queue and it will put that job into a processor for the execution. Again, in scheduler, how many schedulers we have? Long-term scheduler, medium-term scheduler and short-term. Long-term scheduler is nothing but will select all the jobs. Okay, will select all the jobs and will maintain a queue. That is nothing but the job long-term scheduler. Clear? The second one is a medium-term scheduler. Medium-term scheduler is, example, one process is running and another process is entered into a queue which is having a more priority. Then what happened? We'll move the current process from the processor and we'll load the new process into a CPU. So that is done by the medium scheduler. And the third one is the short-term scheduler. Short-term scheduler is nothing but is a critical scheduler, CPU scheduler. So what happened? It will pick the job and it will load into a CPU. That is a CPU scheduler. Now, in the last class, one point I have not explained, that is context switching. Context switching. Context, already I have given the heading. Context switching. Switching means what? Moving. Okay, moving, and it is a process where CPU moves from one process to another process. Example, here we have a P1. It's a one queue. Here we have only one process. Example, we have a two process we have, and here CPU. So each and every process should be loaded into CPU. This is the CPU. So first P1 is executing. Next, when P1 is executing, a new process is entered into a queue. The process name is P3, and which is the most priority. Example, for P1 here, 10 milliseconds we need to execute. Next 20 milliseconds. But whichever process is entered into a queue, that is having a low priority, like this 5. So what happened? Here, in the same queue, if you want to execute, what happened? This P3 has to wait 25 milliseconds. 25 plus 10, 35 milliseconds. Okay, so the average waiting time of the process will increase. That will reduce your CPU performance. So what happened? Immediately, presently P1 is executing. Immediately what I will do? P1 is released. It is removed from the CPU and P3 is loaded. That process is called as a context switching. Understood all of you? And when you will get this context switching in a multi-programming environment only, you will get this situation, because in a multi-programming environment only, there are number of processes. So when number of processes, then it may happen to switch between, it may happen to a CPU to switch between a process. Understood all of you? What is this context switching? Moving one process from running state to the ready state and moving one process from ready state to the running state. Understood? Generally, ready state to running. Process will move from ready state to the running. The process which are waiting for the processor time, that will be in a ready queue. The process which are executing inside, that will be a running. So, using a context switching, what we are doing, we are removing a running process from a CPU and we are making that process to wait in a queue. Okay, so what happened? Whichever process is there in a running state, that is moving to the ready state. Whichever process is there in the ready state, that is moving into running state. Understood all of you? Moving from running to ready. Clear? Now, for this also already I have given one example. Already I am explaining in the class. I am in a running state. And when I am taking a class, principal sir has entered into a classroom. And he want to give us some important message. This example already I have given. So what happened? Forcefully I have to give my class to principal sir, because compared to a lecturer, the principal sir is having a more priority. Okay. So what happened? I will be moved from running state and I will give my place to the principal sir. Understood? So I am moving from running state to the ready state and principal sir is moving from ready state to the running state. Understood all of you? Now, when you are doing a context switching, actually this is switching I have explained, context I will explain now. So when you are doing a switching, what happens generally, simply you want to remove a process from running state to the ready state. Okay, so whenever you are moving any process from running state to the ready state, you need to save the context of the running process. Understood? Means information of the running process. Why we are saving, why you should save that, why process should save that? Because when, again this example here, in this example P1 is the running. We moved this P1 into a queue, example is the ready state. So right now what we are executing? P3 we are executing. Okay, P3 is replaced with, P1 is replaced with P3. So again, when P3 completed execution and P2 completed execution, again P1 will enter into a ready queue, in the running state. So what happened? If you want to save the context, so what happened? Again P1 will start from the beginning. Understood? That is called as a context. Clear? So here, when you are moving, when the kernel is moving from, moving a process from a running state to the ready state, it should save the current status, current context of the process, which it is moving from running state to the ready state. And it should load the context of the new process, which is having a more priority. Understood all of you? Okay, moving a process from one state to another state. When a kernel is moving a process from running state to the running ready state, it should save the status, context of the current process. Okay, and it should load the context of a new process. Okay, once you see this, okay, understood. Actually, when this context switching happens, I think you understood the first point. When any process is entered into a ready queue with the highest priority. Okay, so when we started this, the priority of the first process is 10. And example, times. Here we are giving a priority based on the time. Okay, and whichever process entered into a queue, that priority is, means that execution time is 5. Means it is having a more priority. So when any process entered into a ready queue with a higher priority. First point, when the context switch happens. The second one is when any process is waiting for input from any input and output devices. Example, here P1 want some input value from the keyboard. User. This keyboard means is user only. Okay, what happened? So the user is giving a value till that time. Till that time, instead of wasting CPU time, what I will do? I will remove P1 from a processor and I will load the P2 into a processor. At least a nanoseconds will save. Okay, because actually when multiprogramming is running in the system, you should utilize the maximum CPU time so that your system performance will increase. Okay, so the first point is when more priority process entered into ready queue. The second one is when a process is waiting for any input and output, and when any interrupt occurs. Example, you want to load a file. That file is not there in the system. What happened? We'll move the current process into a ready state and ready state process into a run. Understood all of you? This is about context switching. Here. Now, the next topic is process. Operations on process. Operations on process. What is the operations on process is? Example, when any multi-programming is there, multi-process is running inside the system. What operating system will do on that process? What operations the operating system will do on that process? That will come under operations on process. Here, the operating system will perform two operations. One is a process creation and the second one is a process termination. Okay, what is the first one? Process creation, and the second one is a process termination. Clear? Here, what is a process creation? While one process is executing, there may be a situation, it has to create a child process. Here, I will give you one example. Okay? Here, we are writing a program to calculate average or student information. Student information. Under student information, what I want to display is student biodata, student total marks, and student average marks. Okay. Here, what is the actually parent process? Student information is a complete file. In that, how many subparts we have? Student biodata, total marks of the student, and average of the student. So here it is a main process, and this main process is split into a child process. Okay, these are child process. Okay, so we don't know that internally the child process are creating, but actually when any program is consist of subparts, internally in order to increase the program performance, the total whatever parent process is there, that are split into parts, and each and every part is called as a child process. Understood? Each and every part is called as a child process, and this one is called as a parent process. Understood all of you? Now come to the next one. Here now I will explain the topic. There are many situations where a child process can be created, but in two ways you can create a child process. Child process, two ways. I think you all understood how a child process is created. Okay, when parent process consists more number of tasks. So instead of solving only one process all the tasks, it will divide into a subpart that are nothing but the child process. Okay, child process are created in two ways. One, when operating system is loaded, and the second one is by using a fork system call. This already I explained under system calls. Fork system call. Till fork system call is used to create child process. Understood? Clear? So child process can be created in two ways. One is by when operating system is loaded, and the second one by using a fork system call. Okay, actually it is when a first process is created, then we'll use this method. But when just now explained one program, like a user programs, when user want to create a child process, then we'll use the fork system calls. Understood? And here few more points you need to remember when child process is created is, the first one is process creation. Process creation. The second one is process ID. The third one is resource, request resource. And the fourth one is address space. Address space. And the fifth one is execution. Execution. And the sixth one is wait. Okay. Can you see this? Okay, once you go through this. Okay, process creation. Process creation means, already I have explained how the process is created. Process is created with fork system called FORK. Understood? So when main process will given like this, int main. Here in the main function, if I have given like this. P underscore PID example and PID I have given. Okay, here actually what is that? Here if you want to create any new process, you need to give this data structure, the data type of that. Here the PID underscore example T or I you can take. Okay, means what it means, here using that data type you are going to create a child process. Okay, it is a T actually. D and PID equals to 4. Example fork. Okay, so what happened when the interpreter comes to this line? Internally the child process will be created. Okay, so here what you need to think, what you need to consider, fork. Fork is used to create child process. What is the use of the fork system called? It is used to create child process. The main function, example it will be a C programming. Inside that it is a data type. It is used to create a child process. PID, process ID. Now PID equals to fork means it will create a new child process. Here, once you go through that. Clear? Understood? Now, example. If PID is less than 0, example. If it is fork is created means PID equals to 0. If it is less than 0 means the child process has not created. Example, one more. If PID is greater than 0, more number of childs are created. Okay, if more number of childs are created, then the parent process should wait till the execution of the child process. Okay, for the fork, there are 3 situations. When fork is less than 0, PID. Fork means whatever child process is created, that process ID, that child ID is stored in the PID. Okay, if the PID is less than 0, means child has not created. If PID equals to 0, child is created. Okay, next if PID is greater than 0, more number of childs are there, then the parent should wait till the execution of the parent. Understood? Here, PID is used to store the ID of the child process. Now, fork equals to PID. What is the use of this? It will create the child process. And when it creates the child process, whatever process ID is there, that whatever other process ID is there, that is stored inside the PID. So now I am comparing this PID. If PID is less than 0, always PIDs are integers only, means a positive numbers only. If it is less than 0, means it has not created, means some interrupt has occurred. Now, if it is equals to 0, child is created. Now, it is like greater than 0, more number of childs are there, then the parent process should wait till the execution of the child process. This is actually about the for. Now, come to process ID. Already I have explained the process ID in the last class. When any process is created or when process enters into a system, for each and every process, there is a unique number. It's an integer. That is nothing but the process ID. And the operating system will identify each and every process with the process ID. Clear? So that is why for each and every process ID is compulsory. Clear? Now come to a requested resource. Resources means actually in the system what resources the process need. It needs CPU time, it needs some memory, and it needs some devices, and it needs some files. So when any child process is created, by default the parent process will give the resources. But in case if that resources are not sufficient, the child process can take the resources from an operating system. Clear? Now, come to the address space. Address space means actually this child process is a duplicate copy of parent. Okay, address space means address of the child process. Example, I'll give you one example. Your address and your parent address is same, no? Similarly, here the child is a duplicate copy of your parent. So whatever address is there for your parent, that parent process, same address is taken by the child process. Means that same address is given to child process because it is a duplicate of parent process. Next, execution means when child process is created, how the child process and the parent process will be executed. Means they will execute together or they will execute separately. There are two situations. When child process is created, parent and child concurrently they can execute. One situation. The second one, the parent should wait till the child process is completed is execution. Because operating system won't allow the parent process to leave unless until the child process completes its execution. Okay, there are two situations. They can work together, means they can execute together. First one, if the parent process don't want to execute with the child process, then it should wait till the execution of its child process. Clear? Now, the waiting point I forgot to tell you. If child process want to execute, then here it will get a system call in EXEC. Execute system call. Okay, when child process gets this system call, that child process will be executed. Clear all of you? Now, waiting. This point already I have explained. Waiting means when any parent process created the child process. When any parent process created the child process, here what happened? The parent process should wait till the child process has completed its execution. Understood? This is about the process creation. Now, today what we learned, operations and process means when process entered into a system, what operations the operating system will perform. Two operations it will perform. One is the process creation and the second one is the process termination. Today we completed the process creation. In the process creation, 3 or 4 steps I have explained. How to create a process and how the parent process and child process will be executed and when the parent process will wait. Clear? And what resources the child process will get from the parent process and how child process will get ID. Understood all of you? Okay. How many operations the operating system will perform on the process? 2. One is the process creation and the second one is a process termination. To create a process, what system call we are using? fork system call. To execute the process, which system call? Execute, EXEC. Fork, for, to create. EXEC, to execute the process. And wait. And when the parent process is waiting for a child process to complete its execution, then there is a wait system call. I hope you all understood. In the next class, we'll complete the process termination. Means when the process will be terminated. Okay, thank you.